Good afternoon, everyone, and welcome to Taco Tuesday. Today's topic is all about system pressure maintenance and air control. It will be presented by Brett Zerber in a few moments. My name is Rich Medeiros, and I will be the moderator for today's discussion. For those of you that have not tuned in to one of our Taco Tuesday presentations, we want to welcome you along with everyone else. And we go through a couple of well, let me tell you a little bit about the company, then I'll go through the housekeeping items. So Taco Comfort Solutions, a Taco family company, has been in business now 102 years. We actually hit our 100th year anniversary during the height of the COVID disaster. And so we didn't get to celebrate that year, but we're starting to increase our celebration. So again, we've been in business over 100 years now, and it's owned by the White family. John Hazen White Jr. is currently the board of as the I guess what is that, Brett? Is he the board of the chairman of the board? Yeah, I guess he's the chairman
Yeah,
of the board.
that's a nice title.
Yeah. And Cheryl Merchant is our global CEO. And between Cheryl and John and the senior management team, they've done a great job navigating through this very difficult COVID period. So we're very proud of the team that we have, and they're doing a great job. And we always want to give them a shout out for a great job they've been doing.
Hey, Rich, by the way, I just seen a post on, I guess it's called LinkedIn. I'm just starting to get into it a lot. That Cheryl Merchant just became she was crowned Career Achievement Winner, Providence Business News 2022 Businesswoman of the Year. Congratulations,
Nice.
Cheryl Merchant.
Well, congratulations to Cheryl. That's a well-deserved award, and we'll give her a quick round of applause, even though can't. Yeah, there we go. That sounds good. Excellent. Nice job. Okay, a couple of quick things. For those of you who have not met me, again, my name is Rich Medeiros. I'm one of the senior systems engineers and trainers here at TACO. My background is mechanical engineering, and I specialize in the design and engineering of HVAC systems. I am registered as a PE in several states, and I've been doing this for a couple of years. When I asked Brett to kick off the presentation, he'll tell you a little bit about himself. But let's go through some housekeeping items. Just to make sure that our questions can be answered, if you could type into your question area, just say hello, and that way we'll know that the question system is working. And I will take questions. Oh, thanks. I appreciate that. Got quite a few hellos in there. I will take questions continuously during the broadcast, and I will ask Brett to pause periodically so we can answer your questions. We may not get to every single question, but our goal is to cover every question that we can. The next thing is to make sure that everyone can hear me loud and clear and that you can see the first page of Brett. So under the questions thing again, just type, well, I guess you can raise your hand. Is that it, Brett? Yes, you can raise your hand. So under the, you can raise your hand. There you go. I see several hands, so you can hear us and see us okay. Well, that's great. So I am going to go silent, as they say, or go dark. Is that the, like the super spy movies? I always have the super spy guys go dark. But anyway, I'm going to go silent in a couple of seconds here and turn it over to Brett. He's going to tell you a little bit about himself, and then he's going to kick off the presentation. So Brett, take it away. Oh, wait a minute. I'm sorry. Whoa. I got one more housekeeping thing. You'll notice on the in your little dashboard, there's a section of handouts, and we have 4 handouts that Brett has made available today. And you can download them anytime during the presentation, or you can come back toward the end of the presentation. I guess I don't know for sure. So we do the presentation broadcast is available as a recording in 24 hours, and you'll also get a notice if you're interested in getting a certificate for your professional development hour during today's presentation. And that will be available in a link in tomorrow's, you'll get it in tomorrow's email or email to you. And I know you can download the handouts today because I tried that and that works. But I never asked Brett, can can you download the handouts during the recorded session? I don't
You
know that
cannot.
for sure.
You cannot.
Oh, okay. So you can only download today. So we got the downloads available, or handouts rather. You can download them today, and you can do your thing. So sorry for missing that little housekeeping piece. So Brett, why don't you take it away?
Thanks, Rich. Hi, everybody. Brett Zerba, applications engineer, training engineer. I don't know, I got a lot of titles. I've been with the company 25 years, and that gives me access to a lot of titles. But the, the best part is I like to have fun when I'm putting on these presentations. So let's make sure we do that. And Rich mentioned he's been around a while. I've been around a little while as well. And we've learned together that Rich and I both started our careers where you actually did designs by hand. Remember, Rich? We had a T-square and an adjustable one on our table. I can picture it up and down, and oh my
Yeah.
God, computers and CAD. That was
Well, what was the stuff
pre-CAD.
we used to draw originally with sepia? Remember
Sepia.
that?
Oh,
The
that's right.
kind
I
of
forgot
brown.
about that. Oh my God.
Yeah,
Oh,
there was weird stuff. And then we went to Mylar.
Mylar.
It was really cool.
Plotting that out. I think we had someone that actually did that for us. It was in one of my companies. But anyways, let's move forward today. I have a degree in mechanical engineering from the University of New Hampshire. Wildcats, located in Durham, New Hampshire, 1981 grad. I also have a MBA from Johnson and Wales University. And Taco offers, it's a fantastic company. I know there's some Taco folks on, but a lot of you other folks, or some of our reps are on as well. You know, and I need to preach. I need to preach to the choir a little bit, but they stress education. The White family in management stresses education for all of us employees, and they offer that to us as an opportunity. And in my earlier days at Taco, 90s into the early 2000s, I was able to get my MBA through Johnson and Wales University. And they you know, as many companies out there, they covered the cost for it. But the big advantage was they actually brought the professors to Taco, to our facility. And so there was in this particular case, there was, I think, 12 or 13 of us in the class. But so what was nice about it, it was night classes. It wasn't during the day. It was night classes. But the night classes started at 4, 3:30, 4 o'clock, 4:30, whatever, you know, right at the end of the workday, instead of, you know, 6 o'clock, 7 o'clock, or whatever. So it really helped for my family time. But anyways, I digress a little. I do like to spout some positive things in that regard. So let me get into today's presentation. You can see what it's about. And this is, you know, we like to go over some of the items. We're going to give you a nice system overview. Up Water PRV. What is a PRV? I'm not even sure if I'll define it, but maybe we'll figure it out. Air separator, expansion tanks, pressure relief valves, some design tips, you know, some thought processes that we've learned over the years, and might be in some of the documentation, the handouts that are available to you. But HVAC hydronic systems, it's very important to maintain the system pressure, control that system pressure, remove air. I can't emphasize that enough, and that's what we're going to touch upon on today's topics. And why do we need to get air out of a system? We'll read the document, or read that little last statement at the bottom. It can cause issues for our systems, and I'm sure there's well over 200 people on today's presentation. I'm sure some of you folks have lived through some projects where you don't know what the heck's causing the problem until you find out it's a simple air leak or whatever in that regard, and it's causing issues for it can cause issues for almost any piece of equipment attached to the system, right? The coils, oh my God, the coils. And then, you know, we worry about the pumps, the cavitation, pressure issues, maybe air issues or whatnot. And then, you know, you can reduce heat transfer as well. Corrosion, that's you know, that piping, that the black iron pipe you put in there, copper pipe, you get air in there, you're not pressurizing it properly, you can cause corrosion, quick corrosion on systems, and boom, that's going to cause real big issues down the road. So, you know, there's some reasons for it. It may seem like a simple thing, but nonetheless, you do have to concern yourself with it as you go. So here's some components of an air control system, right? We're going to talk about air control, removing air as well, but air controls. So you got the system filled pressure reducing valve, right? So that we'll show you some sketches of that. I think most of, if all our engineering friends on here, your documents probably have the detail of that. I've seen on many of the MEP drawings. I think it's a copy and paste or whatever for most of the MEP drawings out there. It's pretty straightforward, but nonetheless, that's an important component. The air separator, right? The air separator helps. And Rich has done many presentations, and I have as well, but his presentation on expansion tanks, how important that piece of equipment is to the air control of the system as well, and the pressurization of the system. And then the relief valves, you know, we talk about the relief valves usually probably up on the higher point protecting it, but those are all the different components of the air control system, and we'll touch upon all of them and give you some design tips, and maybe please, if you have some added thoughts on design tips, I like to learn on a daily basis. That's what keeps me as young as I can be. I just turned 63 a couple of weeks ago. I know, you guys all know I don't look it, but that's another whole story. Just kidding. So here's some of the components, and please, Rich and I always stress, don't take a picture of this and send it to your contractor for installation. This is for show me purposes only, but you can kind of see some of the components that I just talked about. There's that expansion tank down there, right? And see all this green equipment? HAECO loves green equipment, Feels free to specify it and BOD it anytime you want. You know, I digress a little bit, but if you want to put in your specifications, the pump, expansion tank, and air and dirt separator must be green, feel free. I'm just kidding. Well, not really, but I'm just
Well,
kidding.
green is a good thing. It's not just the color of our stuff, but it's like it's like the green planet.
That's right. I forgot about that. You know, that's a big deal these days, and it's also at least in the States, the color of money, right, Rich? It's the color of
Yeah,
money.
I mean the original owner of the company was John's. What was it? His grandfather?
Yeah, Elwood white. Elwood.
Yeah. I mean, the fact that he picked green, he was actually was seeing into the future.
Yeah.
That's pretty cool.
Some of the guests have been at our facility when Johnny, the current owner, the current white owner of the company, comes in and talks to us, and some people, how'd you choose the green color? And he'll make up a story, this, that, and the other thing. But the bottom line is, he really doesn't know. He really doesn't know how his grandfather chose green, and his father kept it going as the color of it. Probably got a special deal at the paint store, you know, if I know the whites back then. But nonetheless, there's some of the components that we're talking about, the PRV, you know, and there's that city water supply, you know, and the bypass, and we're going to talk about that. There's that air and dirt separator, and you can kind of see where in this location, where we'll talk about that in design tips. Hopefully your details all show relatively close to these locations for those pieces of equipment. It's pretty common, pretty straightforward, but nonetheless, there's a quick sketch design of it. And again, I bet you if you haven't looked at your MEP drawings, I wouldn't be surprised if there's a detail similar to this. Obviously, it's not going to be identical, but I wouldn't be surprised if there's some type of detail similar to this for you as well. Make Up Water PRV. So what's it do? You know, the pressure relief valve, fill hydronic system with water, right? Well, that's one of the things that it does, and it continues to do there. And it corrects the lowest pressure, maintains that pressure. And you'll see what I mean by that when I show you a couple of designs. So it's important that it helps maintain that proper pressure in the system. Ensures system stays filled, right? I mean, if you're going to lose some water to some little leaks or whatever, it does ensure that the system stays filled. And as with the expansion tank as well, it helps constant pressure at their pumps, right? Pumps have constant pressure at their suction. Very, very important in the design of our systems, in the operation of our systems. Pumps do not like swings in pressure on that suction side. They'll add pressure to the system, right? That's what they do. We've gone over that in some of our presentations before, you know, on other presentations. But on that suction side, and I know a couple of our folks from our customer service and folks are on here, and they get calls about issues with pumps making noise. So that this could be one of the causes here if there's some issues in that regard. There's that sketch again, just so you can kind of see it again. So let's talk about the sizing of it. You know, here's and it's very similar to other designs we've looked at, but you need to calculate that setting, okay? And here's a very simple design. Rich and I like simple math, and we're going to go over some of the equations and how we get to there. But you got 80 feet, roughly an 80 feet foot equipment, you know, and you know, you round it off, right? Obviously the center lines may be up 4 feet, not 4 feet, but a couple feet off the ground or whatever. But you know, you get the overall height there, and you divide it by 2.31. That's a conversion factor, and I'll show you what that is very, very shortly. And that equals to roughly 35 psi. That gets the water, you know, that to the top. You got to get it all the way to the top. But you need a safety factor as well. And, you know, simple math, I'm adding a 5. You could add 7, 10. It's really what your office or what you think is reliable. So that's what the pressure reducing valve would be set at, right? Pretty straightforward, as you can see in this example here. Determining system fill pressure. Pretty straightforward. You know, and obviously it depends on the size of the building or height of the building. Not size, height, right? So we're assuming the pipe is going to go all the way up to the top, So how do you maintain it? Pressure maintenance, right? System pressure maintenance. Pressure reducing valve is usually located on the makeup water line, and I showed you that on that sketch, right? Set the fill system with water to its highest point. So you got to be able to get that water all the way up to its highest point, and with a little safety, right? You want to get the air out of the system, especially during startup. You got to keep getting that air out of the system. And there's that little equation, right? 1 pound of pressure, 1 psi equals 2.31 feet. That's why I divided it by 2.31 on my previous slide. And then it also, 1 pound of pressure, right? That 2.31 lifts a column of water 2.31 feet. Okay, so 1 psi lifts that 2.31 feet. That's the equation of it. So you divide the building height by 2.31. It's a relatively straightforward equation, and you add 5 or 7 or 10 or 6 or 2 or something. But I probably wouldn't go as low as 2. I think most people limit it to 5. Wouldn't you say, Rich, 5 is probably as low as you would recommend?
Yeah, that's probably the most popular value, but it's interesting, Brett. I was talking to some folks about a week or so ago, and their office standard was add 20, which I thought was
Wow.
kind of interesting, but that was their office standard. But like you said, you can make it 5 or slightly greater. In this particular group, they like 20.
But
I
you
like
know,
5.
from a technical standpoint, you need more than the minimum, right? So how much more, you need to determine that, right? So
Yeah.
yeah, I mean it's pretty straightforward in that regard. So that's the bottom line. And here's a detail of it here: pressure reducing valve with a quick bypass fill line. What we're talking about here, and I'm going to talk about some design tips on this, is you probably when I start looking at the sizes of this and whatnot, you're probably not going to want to fill the system through this. You're going to have a quick fill bypass. Pretty common in our industry, so that's what we're looking at here. And on many of our components around pumps. I mean, I'm sure my good friend Drew, who's on the line, can't stress enough. Rich and I and others can't stress enough. Put gauges on your detailed drawings. At least then you got, as an engineer, you have some recall if they're not installed or whatever. Properly sized gauges, properly, you know, make sure they meet the proper criteria. Other presentations we've done, people have said, you know, make sure the scaling is right on the gauge, right? Don't go 0 to 500 when the system's only going to go up to 50 or something to that regard. Anyways, it's pretty straightforward, quick fill bypass there. So here's some of the design tips, right? Most people size it at 3/4 or 1 inch, even for larger systems for the PRV. But you think about it, what's one of its jobs is to keep water in the system. Well, if there's a big leak in the system, you know, you don't want too much water going in, right? So until it can be caught, you know, I know that based on it's happened one time in a previous house I owned where the water tank leaked, and you know, it just kept filling the basement up until we were able to catch it. So keep that. And then size your bypass. I was just talking about that right back here. Size your bypass or think about it on how fast you want to fill that initial system be filled, right? A couple, 3 inches or whatever in that regard. So, you know, it's going to take a while to fill a complete system, right? You think about thousands of gallons or whatnot, but nonetheless, you know, obviously if you can get it to 2, 3 inches, 4 inches or whatever. And then, as we showed before, locate it in or around the air separator and expansion tanks on the suction side of the pumps, lowest pressure area, right? No pressure change. That's why these things are located or suggested to be located there. So that's some of the reasons why there. And to reemphasize, please, isolation valves. I don't think us engineers can show enough of them. You know, how many times are you on a job site and you want to shut some, or there's an issue going on and you got to go find the closest isolation valve, right? Becomes a pain in the neck. Hey, Joe, oh, well, where is it? Oh, it's way down there, you know, at the end of the hall. Okay, I'll go shut it off. Oh, but, you know, and it affects everybody else. So isolation valves, pressure gauges, they're just important small items that you show on your drawings. And I'm sure I'm preaching to the choir to most of you, but you know, sometimes the littlest things are missed. So that's why we like to emphasize that as much as we can.
So Brett, we have a couple of quick questions.
Oh yeah, that's a good point for questions.
Yeah, let's go back to the diagram.
All right.
The first question, nope, not that one. The one, yes, that's that one. So the first question is, is from John, and it says, do you need to specify the pressure upstream of the pressure reducing valve, which upstream is to the left on this diagram, upstream.
Oh, this side?
Yeah. Do you need to specify the pressure? And I've got a couple of ideas for an answer. Brett, did you want to grab that
I would
one?
suggest the more information you put on there, the better. If you know what the city water pressure is. So yes, what are your thoughts, Rich?
Same thing. If you know what the city water pressure is, it would be good to list that. And generally speaking, most cities, I'm going to go out on a bit of a limb here, especially
Be
most.
careful, that limb gets crickety.
Yeah, but I was gonna say most modern cities, fairly new cities, the city water pressure is relatively constant, and so you know you would want to find out in most construction projects that will do a hydrant flow pressure test in the street where the building is going in, and they know what the pressure is before you start the design. But it's a good idea to list the pressure. You can't. I want to kind of make sure the question was, do you need to specify the pressure? And so we can't dictate the city water pressure because it is what it is. So in other words, if the city water pressure in Brett's example, let's assume the city water supply had a pressure of 80 pounds. Well, I think, Brett, you said all you need for your system was 40 pounds. So the pressure reducing valve would maintain that on the downstream side at 40 pounds. But now here's where the but always comes in. In some older cities, and Boston is one of those older cities, Boston, Massachusetts, it turns out there are some areas of the city where the city water supply pressure is not only is it relatively low, but it tends to fluctuate during the day depending on demand in and around the city. The pipes are old, they're kind of rickety and all that kind of stuff. So it's not so much that you're specifying the upstream pressure, but you would list, and I would recommend you list that pressure in using the terminology, city water pressure has been measured, and you put in a range. Let's say it was measured between 70 and 80 psi. It's a good reference thing. The other piece of the puzzle is, and I'm just going to, I'm not saying that city water pressure is this high, but let's assume that the city water pressure was 100 pounds. I don't think they generally are, but let's say it was. You'd want to make sure that the PRV was selected so that it had, in our case, the ability to control the discharge from 100 down to 40. But most existing city water supplies are relatively, this is the part I'm going in on the limb again, Brett. And most of them are relatively constant, and um, they're within a reasonable value of somewhere between 60 and 80 pounds. Okay, we got another question here. It says, after a system's operating, why not close the valve for a period of time to see if there are any leaks? Did you want to take that one, Brett?
I never like to close the valve unless I'm testing the system, right, Rich? You know what I mean?
Yes.
I wouldn't just go ahead and close it. I'm sure that's not what the question suggested by any stretch, but that is a way to try to track down or to investigate, I guess I should say.
Yeah, so the part of the issue here is that when a system is first, especially when it's first started up, there is air in the system, and we have air and dirt separators. That's going to remove the air. That's going to reduce the minimum pressure, and there are air vents. So as air finds its way to the top of the building and collects in the high points, it's going to come out. And so as air comes out, if the valve was closed off, there was nothing to make up that displacement as the water pressure drops down. So there are two separate functions. One is to test for leaks, and the other is to, when you test for leaks, you pressurize the system, you isolate it, and then you look for leaks. And the other one is that you want to make sure that the PRV is operational once the system is initially filled and purged, so that any air that leaks out, the PRV will make up for the pressure as the air reduces the pressure.
I tell you, testing for leaks, and this may not be that much applicable, but never on a system like this test for leaks with air. Test for leaks with water.
So we did have a comment from Rick W. I don't know what Rick's last name, but anyway, he says not here in New Orleans. So Rick, if you could type in, are you saying that that your experience in New Orleans is that the pressure varies and that it's relatively low? I think that's true of most of the older cities throughout the United States and Canada.
I wouldn't be surprised. I wouldn't be surprised.
So that brings us up to date on questions. Brett, take it away.
Excellent.
Oh,
where was I?
Rick says yes. Rick says yes.
Yes. Okay. For New Orleans. New Orleans. Well, that's what happens when you design a city below sea level, you know. But anyways, that's another whole discussion. So air separator, that's another part, another component of it. You know, three basic types: inline, tangential, air and dirt. And if these are TACOs as well as others, and our coalescing one is the 4900 series. And I'm going to advertise that a little bit. And trust me, we're not the only folks that make them. And from my opinion, inline, good air removal, efficiency with low pressure drop, right, with and without strainer. So you can actually get a strainer in there to help get rid of dirt. You know, we're not really concentrating that much on this presentation about removing dirt, but the more you can get out of the system of dirt and, you know, grime and whatnot, the better as well. And that's what this 4900 does for us. And then you have the tangential, slightly higher efficiency at full system flow, but pressure drop and operation cost penalty. So, you know, those are kind of the older styles, and maybe a lot of your MEP drawings show them. And it does need higher velocities, and you can get it with or without strainer as well. But I recommend nowadays get the inline type. That is the 4900 air and dirt type. Ultra high efficiency air and dirt removal with surface area medium. Enhanced. They work really good. It's the coalescing type. Upgrade your specs or think about it. Actually, my recommendation, if you don't know a lot about it, get in touch with your trusted TACO rep and learn about this 4900 and have them give you some ideas. And again, it's not a sole source. You know, as much as I want you to BOD TACO and specify TACO, but you know why? Because I work for TACO. But yeah, well, I think it's the best product too. But anyways, it's not sole sourcing, but really, in the long run, these type of air and dirt separators really save the system. They make the system last longer, right? They're going to get all the air and dirt out. We have testing data on it. I mean, we paid thousands of dollars for this company in the Netherlands to test our product to prove that how much it removes, and it actually is. It actually removes so much air it sucks air into the system eventually, believe it or not. And you know, when I first started many moons ago designing piping systems, you know, I think I put a strainer on every piece of equipment. Oh, you got to put a strainer on every piece of equipment. So I always did, right? I mean, how many times when you first start in a job, somebody tells you to do something, and 20 years later you're still doing it, and you're saying, why do I do that anyways? Oh, because I was told to 20 years ago. But anyways, really, there's a good possibility that you can remove these strainers, and you should remove these strainers. You know, and that's taking away some pressure drops, taking away a piece of equipment that needs servicing, right? It's going to get clogged. You know, strainers get clogged. That's what they do. You know, and I don't know how many times I have had situations where you go over and you take the screen out of a strainer and you remove everything that's in there and you put it back in, and all of a sudden some of the issues go away. But nonetheless, air separators. And again, I really want to re-emphasize, why do we want to get rid of air? Because it increases. You know, you could see, I'm not even going to read it again, but it causes problems, right? It causes problems in a system. And I like to show this this graph. It actually looks like a slide at a carnival, you know, if you think about it, if you want to go fast or whatnot. But solubility, I think I said that right, of air in a hydronic system, lowest solubility is at the lowest pressure and highest temperature. So that's why another reason why you try to locate some of this equipment on the suction side of the pump. That's where you're going to see both of those conditions. So that's where that's important in that regard. I'm not going to spend a lot of time on these charts. In 2 weeks, Rich is going to talk about charts galore. So make sure you come back for that. But here's a kind of a cutaway of not a cutaway, but a side view of a TACO air separator. Reduces velocity, changing direction of flow, and it, you know, the bubbles go up and they go out. That's kind of the old style, and many of the MEP drawing details may still show, you know, going in up high and coming out at the bottom. And we manufacture these on a daily basis, so don't our competitors. By the way, all of ours are ASME rated. All of our products, all of our air separators are ASME rated. Very, very important. It's a pressure vessel. It should be ASME rated. So that's a welding certificate, I guess, in layman's terms. That's what that stands for. But here's the 4900 one that I talk about a lot. It complete elimination of air and dirt, down to 18 microns, and you can see some of the maximum, you know, 150 psi. We can actually go up higher if you get in touch with your TACO rep, if you had a higher system, you know, or whatnot, higher requirement. And we use the pawl ring technology. Other people may use brushes in there or whatnot, but again, you can see it's a really inline type. And I'll have a little cutaway as well. And so I don't need to, I think I already talked about this, but it works good on heating and cooling systems. You can get it with a removable cover, so you can actually take the basket out. I'm going to show you that and clean that pretty easily as well. And down here at the bottom, we have a 2-inch ball valve, so you can actually get a cleaning wand, because this area here is a cavity. So the basket sits in this area here, so you can actually get a wand up there and blow it around and clean that out to get all the dirt that settles down there. So very, very, very efficient items. Matter of fact, one of the handouts is an I&O manual on these. Actually, there's 2 handouts related to the 4900s. One is for the smaller ones. So we do have some from, when I say smaller, in 3/4 inch up to 2 inch are a little different in design. They still have the pawl rings and installation requirements than the bigger ones, 3 inch and above, or 2.5 inches and above. So there's two different manuals there that you have in that regard. Here's the actual basket that sits in there, and these are pawl rings. And I wouldn't be surprised. I wouldn't be surprised if there's some people in the audience today that might even have a pawl ring that they took, because we throw them at people. You know, we hand them out by throwing them at people when they come to the Fall River facility. But it really, if you think about it, the water goes in, right, and it changes directions, and the air bubbles start to form, and then they start to get bigger as they go up, and then they go up at the bottom, and then the dirt particles fall down into that cavity below. So very, very efficient. So that's the pawl ring process. And again, one of the biggest competitors, brand S, has brushes that they use. Again, coalescing type air and dirt separators. Here's some design tips for the air separators. In most cases, people size them according to main system line size. Pretty straightforward, right? You know, if you got a 4-inch main, put in a 4-inch air and dirt separator. I don't think I need to harp on that too much. And again, most of the time, you locate them with the expansion tank and make up water on the suction side of the system pumps, as that diagram showed. Nice location for them right there, and they work wonders there. And I have seen, and this is a good suggestion, you know, if you think outside the box, that some people place small ones at high points to remove air and cleaning the system as well. You know, on some of the runouts on some of the places. So that's something to think about if you wanted to look in that regard. It doesn't happen that often, but it is something you could consider. And if you had some questions on that, contact your TACO rep, and they can give you some more details in that regard as well. So I'm going to talk about expansion tanks, another component. Any questions on the air and dirt separators, Rich?
Yeah, we actually had a couple of quick questions. Let's see. I think you may have already answered this question.
Yeah.
Let's see. What is the maximum flow through these units, through these air and dirt separators?
We design them. If you'd have to go to the chart, because it's all based on the size. But if you stay within the range shown in our chart, I don't think it's on the installation manual that I sent, but it is on the website. You'll have a less than 2 psi pressure drop across them. So it is a very highly efficient piece of product. But I can't really give you the maximum flow through these. It's based on line size. It's pretty much what, you know, if you have a 4-inch pipe, it's based on the 4-inch line size going through there for the most part.
So here's another question. This is a great one. I like this one. How often is it typical for the blowdown valve to be opened at the, yeah? How often
During,
should?
you know, it depends out there. I
That's
would
why I
suggest,
like this question. I think I know where you're going with the answer, Brett.
Yeah, I'm going to do some wordsmithing and jumping around to the best of my ability. At the beginning, when a system is first started up, I would suggest that you do it relatively often, maybe once a week, if to make sure that the initial startup. You think about a startup of an HVAC hydronic system, right? There's dirt in there. I think we all know that from the welding, you know, and the pipes sitting around and whatnot. So you got to clean it out. So you want to make sure that is all taken care of. But then I wouldn't be surprised if once the system, you know, is operational for a couple of months, I bet you could change that strategy to once a month, and then you look at it. And if there's not much in there, then you can even send it out a little farther. We've had some systems where we got a call and saying our air and dirt separator isn't working anymore. How come? Because when I blow it down, there's nothing but clean water coming out. That's good. That's good. That means your system is clean and it's done its job, and you know it'll catch anything on the rebound, right? But there's other systems maybe you got some underground piping, it's got some leaks in it, sand is getting in there or whatnot, you need to do it a little more frequently. It's really, I always hate to say case by case basis, but I don't think one answer fits it all. Wouldn't you agree, Rich?
Yeah, I was trying to come up with some kind of cute little phrase, the dirtier you are, the more you open the valve.
Yeah.
But yeah, you're absolutely right. I mean, you basically need to open that valve very, very frequently when you first start up the system, and then monitor to see how clean the water is, and then you can change your schedule accordingly. But yeah, I mean, the key to the whole thing is how dirty is it when you first start it up? That's the
I
and
I
then like
I
we've
I,
seen.
re- I really I really think that over time, now a condenser water system may be a little different, or some type of open system like that, but any closed loop system over time, I wouldn't be surprised if you could stretch it out for a long, long time. But you got to feel it out yourself. The maintenance guy has to give a report back, and you got to look at it in that regard. So
Yeah, I had a project though. This is going back more years than I want to admit to. It was an extension of an existing system, and so they put they extended the piping, put new piping for the addition on the building and stuff. And they called up and said, "Wow, the system's not working." I said, "Well, let's go out and take a look at it." And we pulled the strainer on a couple of uh, cooling coils, and they were plugged solid with junk. And I said, "Well, geez, where's your what's the air and dirt separator doing in your existing system?" Because we extended the piping in the existing system. So we don't have an air and dirt separator. Oh my God, they've been running the system for like 30 years. No air and dirt separator. It took weeks to get all the junk out of the system. It was
yeah,
unbelievable.
yeah. I mean, actually, if you go to our website, we have a couple of sales brochures, testimonials. One from Florida State and one from a local company in Providence. How much these units cleaned up their system. Go read them yourself. I don't want to get into too much advertising in that regard. So
We
I'm
have
going
a
to move
couple
on.
of other questions, Brett,
All
but
right.
I'm going to hold off until because I think you're getting close to the end here.
Yep.
Uh, I'll
Yeah.
wait to finish up and we'll ask the balance of these questions.
Super, super. So another component of this of the air control system is the expansion tank, right? And I list, and we've done other. Rich has done a great job on other presentations on expansion tank sizing and the different types. And most of you know all these. So I do at least like to mention them. You got the plain steel tank. That's the old style. Hopefully nobody on this call is specifying those for any new projects. If you are, call your TACO rep and become familiar with some other ones. And then a diaphragm, they work. They're a partial acceptance. They are pressurized, but they are throwaways. Okay, you can't fix them in the field. And maybe for some smaller type systems, I wouldn't be surprised if people install some of these on those. And then you have the bladder style tanks. Partial acceptance and full acceptance. I'm going to show you some pictures of them as well. From my perspective, for most commercial applications, specify these here. Any of these will work if they're sized correctly. Stay away from the old plain steel tanks. I'm sure there's some out there in your neck of the woods, and you might have to get involved with a project replacing them or double whatever. But nonetheless, these are the newer types, and any of them will work, and they work fine as long as they're sized correctly. But for most people nowadays, it's the full acceptance, and what I mean by that is the bladder. That's what this is over here. The bladder fills up the whole size of it here in that regard. So these are the bladder style full acceptance. It's the TACO model CA. And again, we're not the only folks that do them out there. That manufacture them and supply them out there. So just keep that in mind. This is a cutaway in that regard. In this bladder, it's designed to last 15, 20 years and probably even longer in the properly sized and working system. Very, very rugged type, but it can be replaced in the field, so it is field replaceable. And again, one of the sheets is the I&O manual for expansion tanks. Make sure take a glance at it. Take a glance at it when you get a minute. Learn from it, and I'm sure others are very similar to it. But there's some critical items in there as far as starting it, not starting it up, but starting the system up and how important it is to do certain things with it. We're not going to get into all that detail, but it does play a very important part of controlling the pressure in a system as well. Here's the CBX style. This is a partial acceptance. You can see this bladder just doesn't get as fill up as big here. This is replaceable as well. And again, which application for what? It's really your call in that regard. This one costs less. They all cost. The diaphragm costs less than the partial, and the partial costs less than the full acceptance. But in the scheme of things, in a big HVAC system, I'm not going to say it's pennies, but the percentage is very, very low. So just keep that in mind. And you don't have to use just one, right? I've seen projects where they've put 3 of these in there just from a size standpoint. So when we talk about floor space, or you think about floor space, you can look at that in that regard as well. And that bladder is replaceable, and the TACO model is a CBX in that regard. And here's the diaphragm. And again, mostly on smaller jobs, but this diaphragm, it's welded in there, so it's not replaceable. So it's our CX series, but so that's why I say it's a throwaway. But again, it's going to last for a very long time. But the sizing is just a little different in that regard. Here's kind of a cutaway, not kind of. Here is a cutaway of a plain steel tank. They're a lot bigger because it's just water and air. There's no pressure involved in that. So that's why these are a lot bigger. And many old jobs still have these on there. So we make them. We usually, because it's a direct replacement. As much as somebody might try to talk folks into upgrading their system, they just want a direct replacement. I think most of you have been through that on some projects before. There's some battles you fight and some battles you don't fight, and this is an example of that. So, advantage of using a bladder tank, right? We like to give you some ideas there. It can be installed. The plain steel has to be installed very high in the system. The bladder can be installed on the floor. It could also be installed up high too, but most of the time, so your installation costs can be a lot less. It's inherently a lot smaller because it's pressurized with air, not water. And the water and air do not touch. They don't come in contact with each other in a bladder style tank. So that corrosion, which could cause corrosion, right? Air in a system could cause corrosion, or will cause corrosion. So that is going away. So that it's a lot less risk of getting air to thermal units as well. And very rarely, if at all, do they become waterlogged, which can happen. Some plain steel tips: air control systems with plain steel. The upper seal of the gauge on the gauge glass is often source for leaks. So that's this bad boy up here. There's this gauge glass. This is actually a gauge that shows you the water level. A lot of times that seal leaks. So and that will dry out and air will escape from the plain steel expansion tank. The tank loses its charge and becomes waterlogged. So, and you'll start getting leaking pop-off valves. We just like that. This is just a tip that if you're involved or you get some calls on an older system, right? There's plenty of them out there. But Rich was talking about Boston, New York City, other older communities. They're out there. So if that happens, just remember this little tip here, and maybe you can help somebody out in that regard. Some do's and don'ts of air control. Do's and don'ts. Don't use a strainer on an air separator because if you have them other ways. Don't put automatic air vents on a plain steel tank. That's just going to cause problems as well. Don't use isolation valves. Do not, between the air separator and the expansion tank. Do not use isolation valves there. Do use isolation valves to isolate the pressure reducing valve so you can bypass it during system fill. Pretty straightforward, right? I think you remember that sketch there, but you need to isolate so you can go around it during system fill as well. Pretty common. It's probably on your MEP drawing on your detail as well. And then for the plain steel tank, check for leaks around there. You know, the old leak test where you put a little water there and see if the bubbles are coming, experience irregularities in your system. So some things to consider in that regard. Here's just a picture to show you a visual of how much space you can save for a plain steel tank to a captive air tank, a CA tank. You know, it's like half as much, if not more. I don't know the exact percentage, but it's a lot less in that regard. So nowadays specify the CA tank or the full bladder expansion tanks. Save yourself and the project a lot of headaches in that regard. Some design tips for expansion tanks. Air traps, right? Make sure you don't have any that run from the air separator to the plain steel expansion tank. Don't automatic vents. I don't think I need to go all of these in here, but I mean, we have a whole hour presentation that Rich does a hell of a job on about size and expansion tanks, right? We have a great program, a selection tool on our website, very easy to use, but you need all of that information, right? System volume, temperature rise, allowable pressure swings, all that information you have to figure out. That system volume, I mean, a lot of people have shortcuts on how to figure it out, but add up the pipe diameters, figure it out per linear inch, linear foot, and do some calculations. Have an idea what the system volume is. You can't oversize it, an expansion tank, but you don't want to undersize it because you're going to have some problems in that regard. So look at this, Rich. We have time for questions.
We have time for questions. Well, we have a few out there.
Excellent.
And yeah, let's see. Let's pick a couple of different ones. I'm going to jump around a little bit. Oh, here's one here. Is it possible to oversize an expansion tank?
Great question. Financially, yes. Size-wise, yes. Technically, no. Actually, the answer is I should have started with no. You cannot oversize an expansion tank. I mean, you could, if you need one that's only needs 500, size 500, and you put one in there that's size 2000, it'll work. 10 days, 365 days a week for 20, 30 years, it'll work. But obviously, there's a financial penalty and a physical size issue with that. Wouldn't you agree with that, Rich?
Yes. Yep.
I mean, it comes down to that regard. But you know, if you're thinking outside the box, system volume, pain in the neck to get, be conservative. Be conservative.
Cool. Okay, here's another one. You ready for this one?
Uh-oh,
For
I'm sitting down.
expansion tank, right? For expansion tanks, how important is a sight glass? How important is a sight glass? This is kind of a trick question. I think they're asking a trick question.
Yeah. I don't think you need them, but they're out there, and we actually offer it as an option. So, but you know, some people like to look inside of things. They're a little more inquisitive. But if you follow the fourth handout I gave is how to check the expansion tank maintenance from a pressurized system, so you can very quickly see if there's an issue with it. But it's your choice. It's your choice. Any comments,
I'm
Rich?
gonna jump in here a little bit and say that a sight glass is only used on a plain steel tank, because if you put a sight glass on a bladder style tank, all you're going to see is air.
Yeah. Yeah. So it's more of a peace of mind than anything, I think. But yeah.
Yeah.
I mean,
Let's see.
Rich, you've specified more than one expansion tank in your career. I don't think you've put sight glasses on any of them, right?
The only ones I ever put the sight
All right.
glasses on was plain steel tanks, so you can
Yep.
see the water level in the tank.
Right.
Let's see. We have a couple of other. This one is it might require more time than we have, but maybe we could give a quick answer. It says, when sizing an expansion tank, how does one determine the maximum tank pressure? That's actually a great question.
It is a great question.
Might be a little bit more lengthy than what we have time for. I'm going to say let's try to get together. Let's see who sent that in. David sent that in. So David, why don't we have you get a hold of us after this presentation, and we can provide a little bit more detail, because it's kind of a lengthy answer.
Yeah, there's no shortcut, quick 2 second answer on that one, or a minute answer, you know.
Yes. So here comes. This was kind of. I think you answered this question earlier. It says I've been. This one comes from Nicholas, and it says I've never been able to find a good answer for what air pressure you should fill in expansion tank. Is it equal to the water pressure? So I think you answered the minimum pressure in the expansion tank and how that relates to the air pressure. And the answer is they're the same.
Right. So it would probably be this setting right here
Correct.
in this example. So the minimum system fill pressure at the pressure reducing valve is the expansion tank and your setting. And it's very important that it's set prior to installation, and the engineer of record should and must be the one that tells people to do it. It's actually in our instruction sheets that before you install it and set it, attach it to the system, you've got to set that pressure. It comes from the factory at 12 psi, because we can't ship components, pressure tanks with pressure in them with any higher value than that. But it needs to be set in the field. And here's an example of that. So pretty much the answer is yes to your question. Correct, Rich?
Yeah, the air pressure has to be equal to the fill pressure that you determine right here. And as Brett said, and I'll repeat it, when we ship our bladder style expansion tanks, they're pressurized at the factory at 12 psi. And that 12 psi is based on the factory, whatever the temperature happens to be in the factory on that particular day. So let's just make up a number. Say it's 70 degrees in the factory, and we pre-charge the tank on the air side to 12 pounds, and we ship it. Well, if it gets to the job site and the temperature happens to be 0 degrees, there'll be a reduction in tank pressure on the air side because there was a change in temperature. But if you ship
Wait
it,
a minute. I am a big fan of the New England Patriots and Tom Brady, and temperature does not affect the pressure inside of football. I'm sorry.
well, it may not affect the pressure inside a football, but it'll definitely affect the pressure inside an expansion tank.
Actually, the instruction sheets spell that all out. It's kind of a little complicated until you kind of read it, as far as making sure you understand the temperature and the value rating or comparison in that regard. So that's very important. But I would say that is probably one of the biggest issues with expansion tank installation. Wouldn't you say that so, Rich? I think our
Yes,
guys get a lot of
and the
calls on that.
simplest way of kind of visualizing that, if we ship the tank with 12 pounds of pressure and you connect it to a system that has been predetermined to have a minimum pressure or the fill valve to be 40 pounds, as soon as you connect to that tank, that bladder is going to start filling with water, which means that eventually it's not going to have the same expansion capacity when the fluid heats up. So yeah, and that's an extremely important thing.
You better make sure you triple the size of it if you're going to not install it correctly.
So we have time for a couple more. I like this one. What are the symptoms of an undersized expansion tank? This is a great question.
Things pop.
Yeah. Yeah. So that's
Water.
when we get that call. We get that call. I say, well, we got everything's installed, but the safety relief valve keeps going off. And then we go through the calculations with the person that's involved with the project, and it turns out that they undersized the expansion tank, and when the fluid heated up, the safety relief valve went off, and so it turns out the tank was too small. So yeah, we get that from time to time.
So if you think about it from a practical standpoint, if the water heats up, the system fluid heats up, it normally expands and goes into the tank. and against the pressure, right? So it fills into that bladder, goes out. If it can't go into that tank, it's going someplace, right, Rich? It's gonna go someplace. It has
It's
to.
going to go somewhere,
So
and if the relief valve doesn't go off, water is incompressible, and if there's no place for the water to go because of the safety relief valve or the expansion tank, something will break.
yeah,
And in my world, it's always the most expensive thing that breaks, right? It's not like
yeah,
a $20 valve somewhere in the system that breaks and causes a leak. It's probably going to
right.
be like $1 million boiler or some crazy thing like that. So we're just about out of time, Brett. Let me see what we got here. Maybe we got time for one more. Uh, no, I don't. We don't. We actually don't. So
Okay.
right now it's just about 1 o'clock. So here's what I'm going to say. If anybody has any additional questions and they'd like to get a hold of us, you can certainly get a hold of either Brett or myself, or you can contact your local rep, and they can help answer the questions, or we can certainly help our rep answer those questions for you. So, so Brett, anything else that you want to add
I
before
just
we?
want to add. I just want to add. Great questions. Thank you, everybody. Appreciate it. Hope you got something out of it. Pretty basic topic, but nonetheless important. And I made some fresh pea soup that I'm gonna go have for lunch right now, and that may gross some people out, but try it. It's really,
Are
really
those
good.
peas that you grew yourself last year and
No,
froze them, Brett?
no, no, no. These are store bought, but the ham bone is fresh from Sunday. I actually got two from my
Wow.
mom and from my brother-in-law. Anyways, thank you, everybody. Rich, take it away.
Well, yeah, I was just going to say, if you've got ham bones, don't give them to your dog.
No, no.
Um, there's a myth out there. I'm going to bust the first myth, is that dogs love to chew on real meat bones, but they can get splintered and they can get
Uh,
stuck in their digestive tract, and it can be all kinds of problems. So don't give your dog real ham bones. So with that, I'm going to say thank you, everyone, for participating in today's presentation. Like I said, if you have some questions that we didn't get a chance to answer, direct your questions toward your local rep. And then if they feel like they need some support, they can always get a hold of Brett and I. We'll be happy to provide some additional information. So with that, I'm going to say thank you very much, and signing off for now. Take care, folks.
bye.